We're going to look now at the resource monitor in relation to the disk usage and memory usage. First, disk usage. We're talking about the hard drive here, not optical disks. But I'm going to demonstrate this by running the optical disk and transferring the contents of an optical disk to a file. Now, right now, it looks like we're running in the 1 megabyte per second range. And there is some writing going on here. As a matter of fact, it just started doing a bunch of stuff. Well, that's because I started recording this video. And when I started recording the video, this Screencast-O-Matic started kicking in, and we're writing that stuff to the disk. We're also writing some logs and so forth to the disk as we go through master file table. So we're writing some file table information, and that began running. However, it's at 1 megabyte per second, and now it just jumped to 10 megabytes per second, and so this got lower, but it's actually higher because now the max here is 10 megabytes per second. But let's see if we can make it really jump. I'm going to begin to transfer the contents of my G drive, which is an optical disc, a DVD, to an ISO file on D Documents, which is one of my hard drives. So let's begin that transfer, and let's watch this thing over here and see what happens. We're at 10 megabytes per second right now and running fairly low in that. Looks like around 10 to 20 megabytes per second, but it's beginning to spike a little bit. Interestingly, we're not having any impact on the CPU. Why are we not having an impact on the CPU? Well, that's because of something called DMA, Direct Memory Access. This allows information to pass through our computer, in this case from the optical drive to our hard drive, without passing through the CPU. It's a resource that is built into all computers today, and this allows this transfer directly across the traces in the computer. Remember the 64-bit architecture? That is that set of wires, so to speak. They're not really wires, they're little conductive traces on the motherboard, and it allows that to go through that. Now we're at 100 megabytes per second, and so again, this looks smaller than it did earlier, but it's really larger because now we're dealing with the 100 megabytes per second. And if you look over here, the 201, 30901, blah, 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 ISO is running at 11 gigabytes per second right now. And that's what you're seeing here. We're not using any more network resource or any more CPU resource, and we're not seeing any more faults per second in our memory. Notice that the memory is not showing how much memory is in use. There is memory in use here, and this is probably using some of that memory, but what's being reported is faults per second. When would faults per second actually get larger? Well, that would happen as we run out of memory. If I'm using a lot more memory than I have, what would occur would be that RAM, or information that's in RAM, would be transferred over to my disk drive, to this disk. It would suddenly start writing to this disk. There's a file on the disk system under C Windows called pagefile.sys, and RAM would get written to that pagefile.sys file, and you would begin to see some faults occur as well. When you begin to see things here and see something happen on this graph, one of two things is going on. Either you have some bad memory, so you have some faults occurring, or you don't have enough memory, and faults begin to occur as that transfer goes back and forth between RAM and the hard disk drive. So this could be an indication of either one of those, and you would have to either add RAM or change out your RAM in order to fix the problem. As this thing ends up now, you'll see that this should drop back down, and this should go back down either to 10 megabytes per second or 1 megabyte per second. as our disk usage drops back out. This thing over here, this ISO file, won't actually drop off for 60 seconds. This number will slowly drop down because this is an average over 60 seconds. And because we haven't completely ended that 60-second period yet, it's going to just look at that number as the average. And so until that end of that 60 seconds, it won't completely drop off. But we won't hang around long enough to see that thing completely drop off the system.